This is an explanation for the Unit 1 discussion. So it says Devin is having difficulty determining if the relation given in input-output table is a function. Marco explains to him that in order to tell if a relation in the table is a function, Devin needs to check if any of the output values are repeated. If they repeat and have different input values, then the relation is not a function. So the rule for like some whatever makes something a function is that each input has exactly one output. So this is what's required to make it a function. I'm gonna make a table based off of what Marco is saying to do. So it says in the second part right here, Devin explains to him that in order to tell if a relation or in a table is a function, Devin needs to check to see if any of the output values are repeated. So let's make a table that has output values repeated and see what that looks like. So let's say this is like 1, 2, 3, 4. And this is like 6, 8, 2, and then 8. So the output value 8 is repeated. So this is like kind of going off what Marco is saying that we need to look out for that's going to make something not a function. And then it says right here, if they repeat and have different input values, then the relation is not a function. But the actual like truth to something that makes something a function is that each input has exactly one output. So by Marco's reasoning, this first table right here would not be a function because we have the output values of 8 are repeated and they have two different inputs. But the rule for a function is that each input has exactly one output. So we have the input 1 goes to 6, input 2 goes to 8, input 3 goes to 2, input 4 goes to 8. So we have 4 different inputs and they all only have one output. I think it's a bit easier to use like the birthday disc or the birthday function in this case, or really just like in any case to make sense of functions. So like let's say I have someone named Sarah, someone named Beth, someone named Mark, and someone named Joe. And the birthday function is a good thing to use when you're trying to like check to see what makes sense. So birthday function is the input is the person and the output is their birthday. So let's say Sarah has a birthday on January 6th. Beth has a birthday on March 7th. Not how you spell March. March 7th. Mark has a birthday on June 20th. And Joe has a birthday on October 10th. Okay, so, oh, wait, actually, hold on. One of these needs to be repeated to match Marco's description. Okay, so Marco's telling Devin that they need to check if any of the output values are repeated. So we've changed the function now to the birthday function, and we have these output values that are repeated. But in real life, like, this is okay. Like, it's okay if Beth and Joe both have the same birthday. There's no issue with that. So the point is that Marco's reasoning is wrong. Like, this having a repeated output is no problem at all. So the next part says determine if Marco is correct. If Marco is correct, respond to the following statement. We've already determined that he's not correct, so we're not going to worry about that part. And then right here it says if Marco's incorrect, respond to the following statement. So explain what is wrong with Marco's reasoning and provide an example of a function. So to kind of explain what is wrong with Marco's reasoning, I'm going to give an example of something that is truly not a function. Because right now, this table is a function. It's totally fine. It's okay for people to share the same birthday. What's not okay is if, let's say I have the same group of people and then Sarah's listed twice. And then, so Sarah has a birthday on January 6th. Beth still has a birthday on March 7th. I don't know why I can't spell March today. March 7th. And then Mark has a birthday on June 20th. And then let's say down here it says that Sarah also has another birthday on October 4th. Okay, so this is an issue. So Sarah can't have more than one birthday. We're assuming it's the same Sarah, like it's not two different Sarahs here. So this is an example of not a function because you have the same input value repeated that goes to two different outputs. So again, the rule for a function is each input has exactly one output. And in this case, the input Sarah has two different outputs, two different birthdays, which isn't possible. You can't have two different birthdays. So this one would be not a function. And that just means that like Marco's reasoning was kind of like the opposite of what it should be. So he says that you need to look for if any of the output values are repeated right here. We just need to check if any of the input values are repeated because it was okay. Let me unhighlight this. It was okay in that first table that the output values were repeated. That didn't cause an issue. What caused an issue was in that second table when the input values are repeated. So underneath here, I'm going to say, it says, explain what is wrong with Marco's reasoning. So for my explanation, I'm going to say you actually need to check to see if any of the input values are repeated. If an input value is repeated and goes to two different outputs, then the relation is not a function. Okay, so for what is wrong with Marco's reasoning, again, Marco says that you need to check to see if any output values are repeated. We did that here. That was no issue because two different people can have the same birthday. What can't happen is the same person, the same input cannot have two different birthdays or two different outputs. So as far as what is wrong with his reasoning, you actually need to check to see if any of the input values are repeated. If an input value is repeated and it goes to two different outputs, then it is not a function. And then if we want to provide an example of our own function, you don't have to create a table necessarily to create your own function. You can write it as a set of points if it is probably easier to type it that way. I'll show you how to do it after. But when you're writing your function, you just need to make sure that you have a bunch of different inputs. So let's say 4, 8, 2, 1. And then like it really doesn't matter what you do with your output because none of the inputs are repeated. So you're not even setting up like an opportunity to break this rule up here that each input has exactly one output because we have 4 different inputs. So like there's no way for 4 to have 2 different outputs if there's only one 4 on the table. So we'll say this is like a 5, this is an 11, 2 goes to 3, and then 1 goes to, I don't know, -7. So each input 4, 8, 2, 1 has exactly one output on the other side of the table. If I wanted to take that same function and write it as like a set of points, I would just list it like in parentheses separated by a comma. So the first row would be 4, 5. The second row would be 8, 11. The next row would be 2, 3. And then the next row would be 1, -7. And then I could write my function just like this, and it's probably a little bit easier to type it like that, but you are able to make a table. In the discussion post, I think you just have to click insert first.